Well, good afternoon, everybody. Welcome to the second last session for today, because obviously the last session is the one where we really get to talk and have a drink and ruminate over all things QA/QC. So this session is our last session after hopefully a glitch that we have now hopefully solved. We're going to have 3 excellent presentations to close out today. This session is going to start with Oscar, and Oscar is going to talk about quality management and sampling, supporting a proactive and integrated reconciliation. I've already read through Oscar's bio, so hopefully, Oscar, you can hear me and are ready to go.
Thank you. So hopefully now you can hear me too. All good. Okay. Well, first of all, I would like to thank Tom Simpson and the Australian Institute of Geoscientists for giving me the chance to talk about quality management. So the context of this presentation is that today in the industry, we do have a big focus on data. A lot of effort to get real-time data and how we can process the data. We want to get data because we want to create a database, we want to optimize, we want to do some statistical analysis, we are talking about planning, uncertainty. In another hand, we are talking about technology, sensors, machine learning, conditional simulation, and automations. So a lot of energy and a lot of effort on how we can use the data. And that's the information we use to feed the metric we normally use in the mining value chain. That's compliance to plan, reconciliation, production accounting. So the main thing is a lot of focus in the data. But when we start talking about, okay, what do we know about the quality of the information? What do we know about the representativeness of the tones, grade, and properties? And especially if we have quantified the precision and accuracy of the information, this is where the answers are not necessarily 100% robust. Every single day, we are working with data and those numbers are compared against our plan. Normally, we are working with numbers with 2 decimals. We do have integrated centers of operations with a lot of screens, a lot of resources looking after the numbers we are generating across the daily production. And again, that's the information we use for reconciliation with the factors, and we have happy faces, unhappy faces, and serious faces. In terms of technology, today in the industry, we are talking about autonomous track, autonomous rig. This is an example for hyperspectral, so we can get the mineralogy from the pits. So again, a lot of effort, a lot of resources in how we can use the data, a post-processing, how we can post-process the data. However, this is the technology we are using normally all around the world. So we are still working with samples. These are pictures from sample stations. And this is happening across the full supply chain. So from resources to port and marketing. So that's the opportunity I would like to share in this presentation. That's what we are calling on quality management, how we can quantify the quality of the different input in the supply chain, but in an integrated perspective. So it's a kind of back to the basics. A lot of effort in how we process the data, but with quality management, we are going in the different direction, trying to ensure the quality and representativeness of the information. So if we had what's the opportunity? If we had the value chain there, we do have different sources of information, drill holes, we have grade control data, we have weightometers, sampling point at processing plants, sample stations, and until marketing when somehow our customers are collecting the data. So the data, we have tones, properties, grade, and again, that's the data we use for the different metrics we use as reconciliation. So as I said, when we ask about the level of knowledge on the quality we have, this is somehow we have a lot of opportunities. And also, because across the supply chain, we have different teams performing QAQC. So sometimes in at the resources level, we have geoscientists doing QAQC. At grade control, we have sometimes a different teams doing some QAQC. At the processing plant, we have a different team, and the same for port and marketing. So we do have different teams looking after quality most of the time with different level of maturity and not necessarily in a standardized way. So because of that, when we have issues in reconciliation, for example, it's typical that marketing can complain to port to processing plant to production, production to grade control, and grade control is going to blame the plan, and then we are going to blame the geological model. So in the absence of a quantified quality data, if we are having issues, we really don't know where the problem is. And that's the opportunity we are tackling with quality management, which refer to the quantification and monitoring of the quality representativeness of the key inputs, but in an integrated perspective. Why integrated, or why that word is important? Because we need to be clear that until processing plan, we are working with ore, but our customers in marketing are not purchasing ore. They are normally purchasing a product. That's why that this silo view needs to be integrated, because we are all at the same team. And if we increase the amount of tons we are delivering to the processing plant, but if we are having issues or at the processing plant or at port, that value disappear. That's why that we need to look after the full value chain in integration in order to really capture the value of our resources. And also, we can go from a kind of reactive approach. So sometimes you do reconciliation once a quarter, once a month, but once you have a unhappy phase, the chip is in China, so it's too late. So we really need to have something monitoring this information to go for a more proactive approach. And something very important is that at the end of the day, we are not doing mining to have a quantified data. So basically everything needs to be related to the value we want to achieve with all the quality controls we have in place. So that's the opportunity we are tackling with quality management. Let's say it in perspective. So we're in a cake mine. So normally we are working with samples. We collect that sample with a specific grain size distribution. And that sample, we send the samples to the lab, and in the lab we have preparation analysis. And after the analysis, we conclude that this is a banana cake, and that's the result, and that's the data we use for the different purposes. So let's say that somehow the plan was saying something different to the banana cake. So the first thing is normally is to blame the lab. Yeah, and normally we put a lot of energy in the lab, and we start complaining to the lab. We send samples to reassign, etc., etc. But if we had the chance to compare the lot versus the samples, we realized that the problem was not in the lab. The problem was in sample collection. So which is the first step. So we need to be very clear that the lab is going to prepare and analyze what they received. But if what they receive is wrong, there is nothing we can do with the laboratory. And also, when we are characterizing the lot, we need to be very clear in what's the grain size distribution, how the grain is distributed within that grain size. This is something that we've been calling the DNA, in order to preserve that DNA across the process. So this is what is happening every single day. We are working with a sample that we send to the lab, we prepare and analyze, and these are the results we use for the data, under the assumption that this data is representative for the piece of core or the pit or the conveyor belt or the port. So it is very important to have well characterized the DNA of the sample in order to have quantified and well understood if the sample we are collecting really represent what we want to represent. So for example, and why this is important, let's say that we are working in a mine with an annual production of 5 million tons with an X million of dollars of revenue. So in some places on sample station, we collect a sample every 5,000 tons, which means that in the whole year, that company will be collecting 1,000 samples. But at the end process in the lab, we normally use 1 gram. So it means that the whole year production of this company, these 5 million tons, is going to be based on just 1 kilogram analyzed. So when you start putting the numbers in perspective, you start giving more emphasis on why this is important, because finally the company's revenue is going to be based in that amount of kilogram analyzed, and then you can start giving or raising the sense of urgency on why this is important. So what do we have, or what's industry, or how industry perceive a quality program? Normally, talking with people all around the world, they say, look, we perform frequent inspections. So in this example, we have a sample station with all this inspection, wheeled up, sample spillage, and all those things. So inspections are very, very important. But the problem is that we cannot quantify the so what. We cannot quantify the impact for the business. Are we overestimating the grade? Are we underestimating the grade? And in the absence of that piece, unfortunately, quality is considered as a cost normally, because we are going to say here, look at this is not working. We need to get a new sample station. So we are talking about $5-10 million investment. But then how we can justify, how we can build the business case, because we don't know if this is something that is overestimating or underestimating the grade. So this is where the lot DNA is becoming important in order to give answers to those pieces. And even in production, sometimes people say, look at, I know that it's important, but look at, I need to use the data and I'm going to use it anyway. Doesn't matter if the data is right or wrong, I need a number to take a decision. So the other piece is, I've been listening people saying, look, we have some duplicate, or our competent person is going to look after the quality. So going back to this example, we have the sample collected, and then we collect a duplicate sample here. So all of them are saying banana cake. So everybody's happy. So the error is close to 0. But the thing is, both can be wrong. So just by having duplicate, both can be wrong. So we need to be careful with the interpretation we are giving to the data we collect. The other piece is, I've been listening people saying, look, we have a person with a master in statistics or simulations or machine learning, or we have an automatic accuracy report. In a previous presentation was very good, because for machine learning, yeah, you have garbage in, garbage out, so the quality of the information is going to be very useful for simulation or for machine learning. But going back to accuracy report, sometimes you can see in the report a scatter plot here. This is the sample weight for duplicate. You can see that is a problem, but you don't know when the problem was. So the other example here is people is very, very proud saying, look, I have this automatic graph, so I can do it in real time. But here clearly the data is here, but you cannot see the information. And also, in QQC report, we can see a lot of statistical analysis and all those things. But QAQC or quality management is more than a statistical analysis. We need to do something else to make the data talk. So for example, the duplicate sample, it's better to see, yeah, this is just a relative difference. You can see the depth and you can see how this rig in particular is performing, and you can see that between August or July and August you were having a problem, and then you went side and you talk with the rig crew, and things change. So you are able to do a better management of the information in order to proactively get actions before it's too late. So what's the opportunity, or when I talk about quantification? So these are suggestions. So in RC drilling, a sample is part of the lot. So as such, we work every single day with a sample, and we try to compare against the lot. So in this bulk sampling, we collect the 1 meter interval, for example, and we compare against the sample we collect, and we can see the level of representativeness we are getting from the sample to the original lot. Similar concept is for blast hole. We can compare the blast hole sampling with the blast cone. So this is around 2 tons. So yeah, around 200 increment are here, but with those 200 increment, you can see the grade distribution, and you can compare the sample against the weighted average of the cone. And in the ideal world, those two lines should be close. And in sample station, you can do some bias test. Bias test concept is something that you can see in the ISO of different commodities. But we prefer to talk about rolling bias test, which is something slightly different. So the strategies is slightly different. In a normal bias test, you stop the belt for several hours trying to get enough amount of samples to get a good statistical analysis. But with a rolling bias test, you do know the maintenance plans, you do know when the belt is going to be stopped. So during the year, you collect a lot of samples across the year, and in that way you can start doing some trend analysis, and you can start monitoring if the sample you are collecting at the bottom here really represent the material we have at the belt. So these are some examples on how you can start doing the quantification of the first step, which is normally the sampling step is, it was mentioned, is where you have between 80 to 90% of the total error is coming here. And as I said, the lab is going to prepare and analyze what they receive. But if what they receive is wrong, there's nothing we can do with the lab. So
Oscar,
in terms
Oscar,
of
you have 5
yes,
minutes. 5 minutes.
yeah, yep. So in terms of few examples, in this here is an F1 reconciliation. There were differences between the resource model and the grade control. Grade control was overestimating the grade. So we saw the blast cone. It looks like that the guys were collecting more of this fine material. So we collect the full cone, and then we compare with the sample, and we were in a condition to demonstrate that the sample was overestimating the grade. And when we do know the number in terms of the difference. So this is an F2 reconciliation result, same thing. The feed grade was greater than the grade control. We did some bias test. In this example, we have two different sample stations. Sample station 1 was the most important one. And the sample station 1 was collecting more fine. So in this commodity was overestimating the grade. So through this, we were in a condition to understand the source of this bias. But even the sample station 2 was collecting a lot of coarse material, so it was underestimating the grade. This is another example of two reconciliation results, but this is comparing two different laboratories with the same certified reference material. We can see that this laboratory was performing quite consistently, slightly a little bit low here, but definitely the grade control laboratory was having a higher variability, but also the average was normally over the certified value. So in that way, we were in a better position to understand the source of that problem. And for F4, we did a bias test at pore. We understood that this concentrate has between 65 and 70% of high grade. So at the processing plant, they were saying, look, we do the same test and normally it's 66, but sometimes we have more than this fine material, and we realized that the processing plant was overestimating the grade. So basically, it is not about just the quality. So it's not about to say in the first example that blast holes were overestimating. It is about to say that this is going to create a difference with the feed grade, which is going to impact the recovery. It's going to impact the tons of the product produced, and then it's going to have a dollar value impact. And the same for the other examples. So it is about to do the connection between the technical things and the dollar value on the business. So as a conclusion with this presentation, I'm trying to highlight the concept of quality management, which is a kind of evolution of the normal QAQC concept, which is more the quality management is given a more integrated and standardized approach across the value chain. Indirectly, with this quality management in the ideal world, we should have a team across the value chain looking after all the quality and monitoring and quantifying all the sources of input of the value chain. And also that the current situation, it is impacting the current production result, but also the future, because new technology needs to be calibrated, and we are going to use the today's data to calibrate. So if the quality of today's data is unknown, that is going to impact the future too. So basically, the plan, the idea is to have a system. So all the mine they need to decide which metric they're going to use and start monitoring the quality of the different inputs. So finally, I would like to say that well, it was mentioned that any post processing data is going to be very reliable on the quality of the information, and the so what, and finally the so what is that there is a paper from Ralph Holmes in iron ore that are saying that just a 0.1% bias in an iron ore mine represent $23 million, just a 0.1% bias. So that is a strong reasons why we need to look after this type of things, going for the current isolated view to something more integrated, and that we are calling quality management. Thank you very much.
Thank you very much, Oscar. Whilst you're still online, we're going to take the opportunity to take some questions. If anyone has any questions of Oscar, we'll get them out of the way now in case we have some connection problems at the end of the session. So does anyone have any questions for Oscar? Hands up. Well, what we might do, Oscar, please stay on for the rest of the session in case there is some questions at the end of the session. But I really appreciate your talk. And looking forward to the next session. The next presentation is by Rod Carlson. I shouldn't really need to read the bio, but this is what's been provided. Rod is Geology Manager at AMC Consultants. He knows his QA/QC and analytical shit from over 35 years of experience in exploration and mining. His talk today meshes in extremely well with Oscar's talk because Oscar was talking about the problems being experienced at market, going all the way back through to the resource model before they end up with the geologist. So Rod's talk is common QAQ issues associated with mineral resource estimates. Thank you.
Thanks, Mark. I will get into it. We've got not a lot of time, and I don't want to hold people up from the beer. So, a few bits and pieces. A lot of this people might have seen before in previous talks, but it's important that you build up to the resource estimate. So, data validity. This is a topical issue. This one, our dear friends in Canada seem to have an ability to be industry leaders in certain areas. And this goes to data quality, and you can rely on data quality that's got good QA/QC, you can't rely on quality that goes through a CEO to be received before it goes to the database. So if you haven't heard about it, look up Red Pine and see the disastrous story that is there with that company. So yeah, you've got to make sure you get the right stuff into the database before you interpret it. I'm going to touch very briefly on a few things. Sampling, we've had lots of good talks about sampling, but again, you've got to be there to see what the issues are. You can't rely on remote geology. You've got to be there to see what happens. What are the drillers doing with your samples as they're going along? Too often these days we see, rigs without geos on them, core being logged, core scan and photography and logged remotely. We've got to be there to see it. Here's yes, it's a laterite, very sticky clays, going through a riffle splitter for sampling and bridging across half of the thing. So you've got a completely biased sample there straight away. So, these sorts of things do happen, but they only happen if you go and look for them. Actually, the same rig at roughly the same time, using this brand new cone splitter technology at the time. And look, it's got this magnificent cone splitter at the bottom portion underneath the cyclone, and a wonderful butterfly valve above it that only opens one way and dumps the sample on one half of the cone, and lo and behold, you got more biased samples. So, that's why we went to the riffle, because the riffle was at least going to be, if managed properly, going to be better than something that was definitely biased. When sampling, you can't necessarily, the things that you know and the things that you don't know. This is just an example from my days at Telfer. We did a lot of very, very careful sampling in Telfer as part of the feasibility study for the opening up of the new mine, and we did some sampling of core on a normal, not an automatic core saw, but on a crosscut saw, and we collected all the fines that were collected in the tray post the core being cut. So you cut the sample, you take your half core sample and compare it against the fines that were collected in the bottom of the core saw tray. Lo and behold, oh God, there was definitely a bias. The actual fines were higher grade than the half core that was cut. Not surprisingly, because the mineralisation associated with sulfides, and the sulfides were fraying away and breaking off and collecting in the bottom of the core saw tray. And look, what does that mean? Well, not much, because at the end of the day, you still got to take your half core as the reliable result. But what is the impact overall? Well, you're probably biasing the grade of the sample down a bit. Here, when you're sampling in nickel laterite country, all sorts of wonderful things happening. In certain parts of the core, here's a beautiful piece of nickel laterite core, and there's a 1 metre run, 1 metre core tray, a 1 metre run that's 1.65 metres long. I beg your pardon? How did we get 1.65 metres out of 1 metre? Well, it's quite easy when you consider the fact that once you've been there and you look at it and you understand it, the driller's not using water. He's actually just coring through the soft clay by advancing the barrel. What does that do? Well, it doesn't wash away the material between your inner annulus and your outer annulus. And where has it got to go? Goes up the tube. So the volume of HQ3 triple tube core at 1 metre is 2.45 times bigger on the outer diameter core. So your volume changes. So that's why you get that happening. And sometimes it's just understanding these things and how do you manage them? What do you do with them? I just brought this in to show, well, soft puggy clays, what do you do to sample that? It's pretty tricky stuff. But if I can just click on this, hopefully it will work. Well, here are our diligent guys at my friendly core shed, taking that beautifully collected half piece of core and smashing it up, chopping it up, putting it into a cone and quarter arrangement. but this is what they've got to do, because clay by its nature is horrible stuff to try and sample. You can dry it up and pulverize it, but if you've got to reduce it down in size before you dry it and pulverize it, what do? Well, this is what they do. They're actually going in, separating the clay, put it in, pull it off, separate it into quarters, layer it back on again, do it 3 times, and eventually end up with a quarter that they take as the sample. So, you know, if you're doing sampling well, it works. If you're not doing sampling well, it really is crap. Density, we've talked about density and some of the pros and cons and methods. I love Rob's whole core tray stuff. That's brilliant. Here's just a few pictures of the sorts of things that can happen. Make sure you are establishing the facts when you're looking at your density. This one I just wanted to show, you know, on the right-hand side of the picture up there is, you know, it's a basic system for taking an Archimedean density. Doesn't need to be fancy, as long as you're collecting the information on the mass dry and mass wet, you can usually get it right. Except when you're in gypsum country. When you're in gypsum country, you put it on the scale and you watch this thing going tick, 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 as it increases in mass as the gypsum soaks up the water. So you can't do that. You've got to do what Robbie does and take your beautifully cut piece of core with the nice, you know, end pieces to measure the length and the width to establish a volumetric density method. So really pick the things that matter, because if you do things wrong, you're going to end up with a really bad result. Duplicate data, look at all your duplicate data, look at how it's responding. Here's some beautiful coarse rejects in a primary and a secondary lab. Lovely result. But how do you interpret the difference between the different duplicates? And this goes to what Mike was talking about. Thanks very much to my mate Biggis over at Newmont, who produces these magnificent graphs that he shared with me around looking at relative difference, looking at the variance and saying, okay, you know, if you look at a field duplicate, coarse field duplicate, what is the distribution over your range, and, you know, do you get better precision in a pulp compared to a field duplicate? Well, thank God, in this case, you do. But the math and the statistical establishing of what's right and what's wrong, it's really critical that you look at all of those issues so that you understand what you're going to end up with in your resource. We can look at plant assays and say, well, when you're doing reconciliation, like we saw in the last talk, what do you get? Oh, look at this beautiful stuff. Gold fire assay duplicates from a rougher tail sample. Look at that. Absolutely perfect. Well, it's amazing. Look at these concentrate duplicates, even better, you know, 60 to 120 gram concentrates. And it's like perfect parallel line data. Why would you ever doubt that? Well, I doubted it, and I found out that the lab was going, oh, they're too different. We've got to get rid of the ones that are outliers and redo it until we get 2 that are exactly the same. I'm sorry, you did what? You know, look, this is where, you know, talk to the lab manager, talk to the lab, find out what their procedures are, because you don't know that that's the case until you talk to them and you do the investigation. If something's too good, it's probably too good and there's something going on behind the case. So don't assume because the data is good that it's really good. You know, the details there. Screenfire gold example. 2 labs, screenfire assayed, biased to one of the labs, okay? Higher in lab 2 compared, so higher in lab 1, no, higher in lab 2 compared to lab 1. Why? You know, they were supposed to use exactly the same method. You know, it's a screenfire assay. It's the gold standard of, get that gold standard. So, but no, the lab 1 procedure was to regrind the plus fraction until it passed a certain level of mass, you know, and then the second lab did multiple fires of the plus fraction and combined the prills with that, you know, mass to give you for those of you who know what screen fire assay is, I'm not going to tell you what it is. So 2 different methods for treating the plus fraction, which is the really important bit. So what did they do? Well, we ended up, tossing lab 1 and keeping lab 2 and, telling them, naughty boys, and get back to doing it the right way. So again, please be careful. Just because it's a really good assay method doesn't necessarily mean that it's right. External duplicates, everybody's talked about them. Bloody well do them and pay for them because they're worth doing. Lab 1 was the one that was at fault. Another example, ICP versus LICO. Most people understand that when you've got sulfur assays at a high level, that your ICP is going to run out of gas, so to speak. It's not going to be able to oxidize all of the sulfur, and that you need an oxidizing furnace like a LICO furnace to actually get reasonable reliability out of your sulfur assays. But until you can compare the two, make sure you do your overrange sulfurs. It's so important, especially in base metal, because in base metals, your density is going to probably be defined by your sulfur assay. You're going to use your sulfur assay in a regression analysis to establish what your density is on a sample by sample basis. So please make sure if you've got a high sulfur sample, use the LICO above round about 10% is what I use. Anything where you're getting more than 10%, always run LICO on your overrange. Lots of information there about why it didn't work. It was basically they didn't put enough nitric into the ICP into the aqua regia digest to fully oxidize all of the sample. So, these are learnings. What I'm trying to say is, please be careful. Here, CRMs. We love CRM characterization studies. What a fabulous thing this is. Here we are looking at 5 labs based in one country, in one city, happens to be Perth. When you can characterize your own standards, and what a great job we did with that. Did you play with my thing? Gee whiz. You can actually see patterns. You can see what the labs are doing by characterizing your standards. You can see they're all dealing with the same sample. They're all dealing with the same process, the same analytical process, and it gives you a picture of who's doing well, who's doing things the same way compared to a lab that might not be. So if you have the need to do a characterization study, I heartily recommend it. Buying from Aureas is a great answer because they do things really well, as we've heard today. But if you do have to do it yourself, you actually learn about the labs that you use rather than necessarily 15 overseas labs that you'll never use during your timeline. And, it just happens that these labs vary over time. We talked about lab management. So resource estimation, getting to the bit that I'm supposed to be talking about most of the time, all of those things lead into this. If we're doing this on a regular basis, we're going to get this at the end of the day. And guess who's in that suit? Yeah, it's me. Thanks very much. We have to be able to see the process. Sometimes it's really hard as a consultant to know that that's the bit at the front end. So if everything is perfect from a data collection point of view, how could we possibly go wrong? We're only doing grade capping. We've got to work out where the top cuts might be if it needs top cutting. We've only got to do variography black magic to work out what the range of the interpretation should be. We've got to set our ranges. We're going to be, what sort of distance are we going to double it? Is it 1.5 or is it 5 times the distance for run 3? What is our maximum number of samples per hole? What's the minimum number of informing samples? What's the number of samples per octant? Are we going to use dynamic anisotropy? There are so many inputs to a mineral resource estimate that make significant difference. 5 minutes. Thanks, Mike. I'm definitely going to have time to finish this. So the answer is that resource estimation QA/QC is QA/QC. It's every step of a resource estimate process is a step that you consciously have to make. You cannot, in a traditional non-machine learning guesswork program, end up with a result that's going to be the same every time unless you apply your brain and you understand the geology, you understand what the mineralogy is doing, that you understand how good the drilling is, what's the drill spacing, lots and lots of rules and regulations that are totally unwritten in most cases. People learn to be resource estimators through some sort of weird morphism from grade control maybe up to resource estimation. And it's through being there and have done it hundreds of times and learning from your mistakes. So I can't talk about QA/QC in a resource estimate because everything is different every single time. You can run your swath plots. You can look at your X, Ys, and Zs and see how your composite grades compare to your block model grades. And you go, oh, yeah, well, that looks pretty good. Oh, no, it's a bit smoothed. But how do you deal with those issues? How do you manage those issues in the interpretation process is the art in resource estimation, as Ian's smirking at me. But the mistakes we've made, exactly, it's the mistakes we've made that you learn from. You can do your visual comparisons to your drilling and go, oh, yeah, there's high grade where I've got high grade in my holes. That's a miracle. Really? Oh. But it's the bit between the drill holes you want to know about that you have no information for. So you've got to have some confidence in your interpolation. And how do you deal with geology? How do you deal with this randomness of geology where you've got multiple orientations of mineralization and you're just trying to get it roughly right? Well, you can do everything perfectly. You've got a beautifully distributed set of results for composites. They look magnificent. You run the bee's knees of estimation. You get a beautiful, localized uniform conditioning model, and somebody comes along and runs a simple histogram on the distribution of nickel grade in your block model for that domain, and you get, oh, how could somebody who spends 4 weeks on an estimate or longer, if you're in a company, you probably get 6 months to do it, end up with something that starts like that, ending up like that? You know, it's possible. It happens. And how do you fix it? Well, you ask the question of them and you go back to them and you go, excuse me, can we just have a little discussion about this? Because it actually impacts how we're going to mine this bloody thing. So don't worry, you can trust me, I'm a geologist. I only have 50 years experience. That's okay. Be real, be realistic in your assessments of resource estimates, be always in the know of not knowing. Always ask the questions, because if you don't, you won't find them. That's what QA/QC is all about. Thank you.
Thank you, Rod. And I'm sure we'll have time to discuss that in more detail, but you definitely need to do that over a beer, white wine, red wine, or champagne. Our final presentation for today is by Renee Stirk. Hopefully, I'm really looking forward to this presentation based on the topic or the title. When Renee has also given me the shortest bio, which is Renee has taken the red pill. Now, I'm a very ignorant person because my understanding of the red pill is you're dead 10 seconds after you've taken it. So Renee is alive and well. And
Absolutely.
he did explain to me the difference between the red pill and the blue pill, and I'll let you do that to the audience today. But his presentation today is titled QAQC, Has Anyone Seen My Dead Horse? Thank you, Renan.
Thanks, Mark. I'm just going to set my own timer here so that I don't get nervous looking at you, Mark. That wonderful shirt. I'm actually a bit at a loss of where to begin. Actually, my last slide is effectively your last word. So I'll go straight to the end because we're saying the same stuff in a different version, right? And as you hear all these really good talks, and I'm actually completely blown away by the quality of the talks because I always joke, I don't like conferences anymore. I'm bored with half of the talks that get presented, not because I'm too smart, I'm just literally not finding inspiration. But to me, this was absolutely a day of inspiration. And as you can probably tell, I'm I'm just like an excited schoolboy. I'm just so excited. I could ask 100 questions. I could stand there for hours, but I'll get stuff thrown at me. So I'm not going to do that. But I am going to take a different course to the other presenters mostly. Not for any other reason than, I could go down all the rabbit holes. And boy, how many rabbit holes are there? I mean, calculated precision, let's go. We could talk for hours and it's fascinating. We can talk about CRMs, we can talk about drill holes, et cetera, war stories. They're so important. It's all been said. But what I want to do is, I guess I want to start by acknowledging, why am I actually even up here? Right? Why are any of us up here? Because I don't have the gray hairs just yet, but I'm sort of floating in the middle, as my kids will have me know, right? I'm almost old, I guess, 47. So do I actually know anything? And the danger is that you stand here preaching and you're actually one of those people that think they know and you don't know. The Dunning-Kruger thing that's been overhyped. We've all heard about that as well. And as a resource geologist, that's the trap, the Dunning-Kruger trap. And I'm, watching this is we want to listen to the war stories. When has it gone wrong? Because you learn from that straight away. I was somebody said every time you go to a lab, you learn something. I was at a mine lab in Africa last week and I learned something new and it was really, really interesting. So you constantly keep learning. So my presentation, or let's just be honest, it's a rant. Right? And some of you who know me know what's coming, but it's more of a journey because I'm coming a little bit left field. I wasn't trained at UWA. No, don't know anybody there. I'm some random dude from Holland. My native language is not English, as you can tell. So I'm fascinated by language. I'm fascinated by it. Just take the JOR code. What a bizarre document. Sorry, I'll take my JOR hat off because I do sit, as does Rod, on the JOR committee. I am absolutely amazed by the wording in it. And I can bore you all day long about why certain things, the must and the shoulds, right? Interesting. The same thing is happening here with QAQC. I was an exploration geologist putting samples into things and doing stuff that other people tell you. And at one point, I hope you go like, hold on. What are we actually trying to do, right? And that is the question. What the hell are we trying to do? And most of this stuff, as I go from side to side to side, because I do have a couple of decades experience in this stuff, and I have the luxury of, I don't know, having seen 400 projects or something, so that's going well for me. I have a framework of reference, I think, even though I'm still learning, but I'm tapping into that to go like, well, why are we doing this? Because a lot of these sites, other than your site, obviously, because that was actually truly wonderful to watch. And I'm going to steal that video the moment it hits YouTube. Most of the sites I go to, it's all the same stuff. Why are you taking duplicates from waste material? I mean, here's 15,000 bucks. Stop doing it. Right. I'll send the invoice. Right. It's crazy. So asking stupid questions is what I'm very good at. And then not feeling, sorry for the outcome, because ultimately sometimes there is a bit of a stupid question. So what I'm going to talk to you about is kind of how I see the world of QAQC, but I don't actually really like talking about QAQC because it's the wrong focus. It's an overhyped concept. It's a couple of letters that get us so boxed into the 1 in 20 crowd. If I ever meet the 1 in 20 guy on the street, I'm going to punch the lights out. I'm done talking about 1 in 20. It's the wrong question to ask. How many standards should I submit to satisfy JORC? Fuck off. I'm not interested, right? It's just not interested. We need to have the conversation at the right level. Now, I'm not saying that I have got all the answers, but I like to think in the more systematic solution to this, and a lot sits into words. And I'm actually really interested in it. Hopefully I can excite you a little bit about that universe. And it actually is obviously aligning what everybody's already said. Oscar just talked about data quality systems. That's the language we need to use. Stop talking about QA/QC, right? And that helps us asking the right questions. Right, now I need to click a button to actually get to a slide, because I must have something to show. So, this whole world of QA/QC, favorite movie, obviously. I'm a kid from the 80s, so, this is awesome. But, we need to move on from this. And this is actually a presentation that is unchanged, as other authors have said. I'll be presenting the same presentation in 10 years' time, and then I'll actually be Bolt, and then in 20 years' time, and I'll have a cane, and it will be the same. And nothing would have changed because there is no new science. I presented last year at a conference. They wanted to know the new science in QA/QC. I'll show you in a couple of slides what I believe the new science is. So I feel that I'm at the 2024 World Conference on the Treatment of Scurvy. That's what I'm thinking I'm doing, right? I mean, it's done, people. We know the treatment for scurvy. We can move on. Right? There is no new solutions. There are new tricks. There's no new software. There's no new science, there's no new statistics, it's all the same, right? So this is interesting because everybody's talking about hobby horses, and I didn't sneak this slide in over lunch because, and it aligns perfectly. We've set all of this up from the start, right? We had a little chat to each other. But so this is why I called my presentation Beating a Dead Horse. That was the last one, I think. That was the GeoHug talk that I did 4 years ago. And now I've just changed it to, has anybody seen my dead horse? Because I can't even beat it anymore. So what we're not going to do is talk about tips on QA/QC and war stories and case studies. We're not going to look at scatter plots, indeed, because those things should be relegated to the back ranks. And we're also not going to bitterly complain about the lack of professional standards, right? I mean, we can do that all day long. Everything is screwed and we're all going to die and it's all terrible. This today was actually super interesting. We got so many good things happening, but we're not getting it out. It's just not coming out, right? I mean, Cliff Stanley wrote his papers in fricking 2009, and Marat wrote his 2011 and 2008 papers. It's done, right? Here they are. So the latest advancements on QA/QC, it's an empty slide because there are none. That's it. And you only have to read these papers. Now, Barry and Linda and so on have added another paper to it, and I've read it, and it's good. But is there anything really new in there? I don't know. I'm not so sure. It's a great summary, and it's open access. So commend them for doing it. But there is nothing really new in there, right? It's all out there. These papers are my favorites, and obviously this one from the 2014 series on mineral resource estimation. Great papers, but it's done. So my learnings, I guess, were seven learnings, because people like bullet points, right? If this would be a YouTube video, I would stand there with a little thing calling 7 things to know or something stupid like that. But let's run through 7 points here quickly. What can you see if you do a lot of this sort of QA/QC work? Well, the why is missing. There's absolute pure dogmatism. We just do stuff. Because you just insert standards because that's what we do. Why the hell are you submitting standards if your lab is submitting the same freaking standards? Sorry, I just took all your revenue away. But why are you submitting these CRMs? Well, useful sometimes, and yes, use them and so on. But if you don't know what you're doing, you're literally just wasting your money on a good cause, obviously, right? But you're throwing your money away because the why is missing. We don't know how to analyze the data. We don't know what to do with it. We don't even know what we're trying to prove. And I'll swear, we talked about hills to die on. Thank you, because I am going to talk about the existential crisis. I love that word, and I wrote it down. It's like I'm gonna take that and use it. I do believe we have an existential crisis. The why is missing. Inserting standards is not actually mandatory. Can we just agree on that? The JOR code doesn't say you shall include. It doesn't say that, right? It's useful to do, but know what you're doing first. So the 1 in 20 crowd, hey, not interested. It depends. That's a classic answer. Any geologist, what do you think about her? Oh, it depends. It's this classic answer to everything. Right. This one is key, right? And this one has broken me as I sort of went through the cycles asking stupid questions, materiality, right? Because we can run a t-test. Oscar just spoke about statistical testing, right? So you run your CRMs, great. And now you have a mean, and you have another mean. And in Holland, in high school, you learn about t-test, of comparing two means. And if you want to be a scientist, that's what they teach you. You know, if you look at two populations of people and they look at, you know, how smart they are, how thick they are, or how tall they are, and then they compare means. And then there is a p-vector. And when you're old enough, you had to look that up in a book somewhere at the back and compare alphas and p's and all that sort of stuff. Statistical significantly different. That's how science works when you're comparing shit. That's how it works. We don't do any of it. Literally. I don't understand why that is. Now, maybe I do, because when it's statistically significantly different, it can still not be material. It does your head in, right? So we are in an existential crisis because when is it good enough? It is a realistic question to ask and a good one to ask, I believe. So, you know, this is after we've seen all the train wrecks today. I'm pointing at that screen, and I should point at that screen, obviously, otherwise I get in trouble. I say projects rarely fail to QA/QC, but we've seen a whole bunch of examples today where that wasn't the case, right? I always joke when I run these courses, those trucks will be driving there tomorrow as well, regardless of that little CRM doing its thing. Don't worry about it, right? Focus on the important stuff. So I think the materiality aspect is something that we need to lift to the foreground, and I'm going to come back to that. When is it important, right? Statistical significance is not the same as materiality, and that's something that we haven't quite captured in all these articles and papers and so on. Right, so here's another learning, but when we talk about QA/QC, obviously that needs to fit in somewhere, right? So SOPs are critical, right? But again, it's because the JUR code says it, right? Or some other code says it. Why are SOPs critical? Because if you're all doing the same stuff, then you're reducing variance. And somebody said this morning that variance isn't important. I got a freaking heart attack, but you know, variance is the resource killer, right? I mean, bias is crap as well, but we want to limit variance. And if I tell you to stand on a scale every morning at the same time to weigh yourself, and that's in my SOP, right? I get far less variable data. But if I go and have breakfast first and then I stand on a scale, right, I have far more variable data. So telling you how to do something reduces variance, but that principle is not sitting in our SOPs. They're just documents so that you can show them to your auditor, say, we got SOPs. Nice, eh? We got SOPs. It's fascinating. You actually take the SOP. If you're doing a proper audit, you take the SOP to that station and say, James, could you just show me what this says? And you say, oh, well, that's not what it says. Oh, we stopped doing that 2 years ago because it isn't working. Well, why the hell is it in this SOP then? Right? So that whole system isn't working in most places I go to. So, and it's fascinating because if you actually talk to the labs, their SOPs are perfect. They are just, and actually, funnily enough, the drillers, right, who are just there standing all day, their SOPs are really, really good if you actually ask for them. Ask for the diamond drillers' SOPs on the rigs. They're really well written, tell you exactly bullet point what to do. So SOPs is a major point of improvement, even though it shouldn't be in 2024. Nobody quantifies accuracy and precision. And we just heard Oscar talk about quantification, and I want to know more, but I find this fascinating. We do this stargazing at scatter plots. You know, there's this wishy-washy process of looking at a scatter plot, and then we go, in a competent person's experience, this is just mightily fine. I don't understand what you can see from a scatter plot other than that's a shitload of scatter, right? There is nothing to really compare with. And listening to Mike talk about the only way to deal with your duplicates this morning, that was fascinating because that's what you need to do. But how many operations do that? I really, honest to God, I haven't come across any yet. Right? So we have to get to a process of quantifying accuracy and precision, and it's possible. And if somebody wants to talk to me after this, because we had a quick chat and I'd love to talk about this, it is possible to quantify it. And if you quantify it, you can do stuff. Because if it was 6 out of 10 last month and it's 7 out of 10 this month, right, there's a difference. You can't do anything with words. We need to get away from these waffly words. Another point, the important connection between variance in sampling and measuring, and variance in a variogram and variance in estimation, the stuff that Rod was talking about, and therefore the quality in our decisions is not understood. You know, the whole duplicates. Duplicates are half-core duplicates are sitting in the ground as 2 half-cores. And if half-core is your standard sample size, right, the average variance between this and this minus that squared, you sum all of them up, divided by 2 times n, there's your variogram, there's your nugget, right? There is a combination, there's a connection between the variogram and your duplicates. So people, I go around these sites and it's that we stopped collecting core duplicates 20 years ago, all the sites I go to. And they go, who is that person that keeps telling everybody to stop collecting core duplicates? Is it any one of you? No? I'm just interested because that's such a missed opportunity. And we heard this morning, why? Because if you've got visible gold and you've got no ORI lines and you've got a fieldy with 1 year experience deciding where to take the sample, I can guarantee you what goes in the sample bag, right? And you can't control that shit if you don't take core duplicates. So the whole precision thing, the whole variance thing is misunderstood and we're not using it. That graph that you showed there, why isn't anybody using that? Right? Because I have the same graph, you gave it to me as well. Opportunities missed. So, you know, variance duplicates are completely underused. That's where the value, forget the CRMs. Again, sorry, it's the duplicates that matter to me anyway. Oh, statistical process control charts. Right. If you are creating CRM plots, and you're writing stuff in your report and you've never heard of special cause variation, stop doing what you're doing, right? I Googled this stuff because I thought, what the hell am I doing? I found a book by a guy called Don Wheeler, and he wrote a book on statistical process control. So I rang the guy up, he's a professor somewhere in the US, said, look, what, can you just look at what we do as an industry? And he looked and said, Jesus Christ, that's weird. Right? And so I started looking into this, and then I talked to you about that. I mentioned in a question this morning, the book by Miller and Miller. They go through endless examples of statistical process control, Q-sum plots, Westgard rules, all sorts of things to actually establish special cause variation as a separation from common cause variation, because that's our only job. We're not here yet for accuracy. The only job that I have in quality control is to say whether the fricking system is in control or not. That's the only job that you have. You're not talking about accuracy just yet. System in control, system out of control. And if the system goes out of control, you stop and you react and you fix and you respond and you move on. That's quality control, as somebody pointed out really well this morning. This point has been made, and I don't think I need to dwell on this, but people have no idea what happens in a lab. Right, so, you know, geologists doing audits of labs is taking pictures of prep station and saying, oh, there's a bit of contamination there, right? Because there's some dust. It's crazy. You need to understand what happens there. And I'm no geochemist, but, you know, there's so much information out there, and this is a missed opportunity for us as an industry. But still, I will stand by this as well. There is way too much focus on the lab. Forget about the lab. It's not your problem most of the time, right? It really is. It's the rig. It's your drilling. It's your primary sample, as we're all told every single time, that RC rig, right? That's a pretty complicated, you know, industry, that RC rig that's sitting there at all its various things that can go wrong. So worry about the right thing. So last point, the purpose of verifications and audits are misunderstood. Verification, you know, NR 43-101, it says data verification. That's a chapter. But why is it not called data validation? And can somebody tell me the freaking difference between verification and validation? Because I'm Dutch and I'm stupid. Tell me, what is it? And then you start looking into it. And the red pine thing that you put up, when I saw that, it's data verification, proving that something exists. And that's important, because if they would have done that verification thing, they would have picked that up. Well, arguably not if it's the MD passing the sample straight to the database geologist. But you should pick that up with data verification. And your audits, we don't have an ISO standard in our industry to do audits, right? And AMC gets called in to do an audit. I get called in to do an audit. What does that mean? I had one client who said, we want you to do an audit. I said, okay, tell me what you mean by that. I can come in and take pictures. I can say, that looks all right. But do you want me to sign something? Do you want me to put a stamp on it? Does it go to the market? What is this audit thing? How deep does it need to be, this audit? You know, this is important. And if you look at the financial industry and you download the ISO documents for way too much money to actually see what you should do, you can borrow concepts from that. So there's a little image, hopefully, that will explain that further. I am going to close, but I might go 30 seconds over. So I'm advocating for this whole of system approach that incidentally Oscar was talking about as well, I think in a similar way. A data quality management system. Let's stop talking about, this is my plea to get to the point. Stop talking about QA/QC and call this a data quality event. And people have already made that comment on the slide. You need to create a data quality management system. And you start with a DQO, please, can we understand the concept of a data quality objective? Without an objective, nothing works, you're just doing stuff. If you don't know what the expected threshold is, it can never pass or fail. This is the thing with duplicates, because we have no established data quality objective. Therefore, we collect duplicates. We get a scatter plot and we go, I don't know what to do now. You need to have thresholds. And if you think that I've made this term up, read some of the literature. The right people are talking about this in the right way. So Barry Smith's paper, they talk about this, thank Christ. And the paper on photoassaying that Simon just wrote talks about this because he knows what he's doing. We need to talk about data quality objectives. Here is a little thing from SDS, sorry, ALS person, from SDS, and it actually has a table in the Rocks to Minerals guide, which you can download for free, by the way. It's really great. And it actually says for different stages, we have different target relative precision and accuracy, a DQO. Right? And you need to define that for your operation, right? Because they'll be different based on your natural inherent variability and so on. This table from Marat's paper that you should all have under your freaking pillows if you're in this industry, this table is a DQO. So when you collect your duplicates in your report, the line that you write is, and that matches the DQO for this style of mineralization for this stage, blah, 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 or something along those lines. And if you do that indeed for your operation, then you will establish your thresholds and now you're cooking with gas, right? So DQOs, and we have them, they exist. Right, write good SOPs, we'll skip that. The whole thing with SPC, you know, these auto-generated plots, I'm done with them. You know, they don't work. You need to create proper plots. This is our own software if anybody's interested that does this properly. This is special cause variation. So here you stop the system, you fix it, so on. Not a month later, doesn't work. Quality control doesn't work. Time is an issue. You have to be there. This is why the lab is the only person who could do quality control in your lab. Putting CRMs in and then 3 weeks later saying something about it is not quality control. It just isn't. I've got a couple more slides, don't worry. I'll skip this. So audits. I said I would come back to it. Audits, internal and external, document everything, obviously, but this is a workflow that we've developed with RSC. If you want to do an audit at a site where you're a geologist going to a lab or to a drill rig, take the SOP, right? If it's not there, say something about it, right? And if it's there, do they talk about objectives? Is there quality control link? Does it actually say what you need to do with quality control? Is it best practice? Have you audited? Are they actually doing what they should be doing? Pass, fail, risk, right? Risk, we're supposed to talk about risk. So this is the last slide. This is what we use, this is what I've developed as what I call my data quality management system. It starts with a DQO, then you do your QA, your SOPs, your QC, which you do during the process. This is before, as somebody pointed out very well, right? It's a timing thing, right? Before, during, and after. Then you do quality acceptance testing. Don't worry about your bias. Don't worry about your precision. That's not your job. Your job is to say whether the system is in control. Whether it's in control, now you can take the data, like this system here. Let me just make my point. This system here wasn't in control. So don't take all of these data and then start comparing a mean. That's statistically, you get shot for that. As a resource geologist, the same as using 2 domains in a single ordinary kriged estimate. You can't do that. You have to say, I'm now using this, And now I'm looking at my accuracy. Now I'm doing my t-test, and I'm doing it separately for that. Right? That's the principle of process control. And in case you're thinking, you know, this weird guy from Holland, get rid of that guy. You know, there is an international standard, ISO 9000, Quality Management Systems, Fundamentals and Vocabulary. Google it, right? It's out there. These systems are out there in other industry. So, Rod, I promised I finished on this slide. I love this quote because to me, it's all about asking the right question. And I'm fascinated by this QA/QC stuff. You know, the questions on why we're doing what we're doing. So thanks for listening. Yeah, any questions? I'm here for another half an hour.
Thank you, Renee. Rod, did you want to come up? Just hang around.
Oh, yeah.
So we have time for questions. I'm not sure, is Oscar still online? Do we know?
Yes.
All right, so if you do have some questions for Oscar, he's still online, so he can answer them. Before we get started, there's a comment that was made earlier, and I'm just going to get Peter to read that out. Do you want to? It's one from someone online.
Yep, this was from Craig Hamlin from Aureus. This is Craig Hamlin, think some confusion still persists here. The term standard reference material is registered with the United States Patent and Trademark Office. We, Aureus, obviously don't use the term for this reason, and also we have seen it used to abbreviate secondary reference material. The term standard gets used all the time and it's not specific. It could refer to a reference material or a certified reference material. Primary solutions are what laboratories use to calibrate their reading instruments as they have lower uncertainties compared to matrix or solid reference materials. That must undergo transformation into a simple solution before it can be read on an instrument such as an ICP or AAS. And he's given a web link for that document, which is www.nist.gov/SRM/SRM-definitions.
So we've got a few minutes left to go before we have a drink. Three excellent presentations this afternoon. I'm sure there must be questions. So does anyone have any questions to start the ball rolling? I'll pass over to Nick, so hold on.
Thanks all you guys for those presentations. They were great. And that a few of the last points in the last presentation, I got a lot out of that. It was good. One of the things, sort of just a quick comment, is that obviously there's a lot of the detail that's sort of displayed there, and even from Oscar's the full management plan. Often, I think one of the missing things, and even you made a very good point about everyone's blaming the lab, and I think that the lab is one of these areas that is the least concern in part of this whole chain because of the many controls that they can control. A lot of it is the geologists and the initial sampling that we're doing. And I think we're losing a lot of especially in Australia, really good training for geologists because of the shutdown of universities, the streamlining of the programs, which is just getting rid of all of the other extra things, which I think we as a group of people need to change that because it's horrible. But one of the other things I just wanted to say on the back end of what Renee, the comments that you made there, do you think that there's a possibility that with all of the QA/QC discussion and trying to beat everything down to graphs and everything, could it be because we're often as geologists, especially when you trend away from exploration into the mining sector, that we're always beholden to engineers and other people in training that often look at things that is quite linear or binary, whereas we're dealing with something that's a little more chaotic and trying to squeeze it into that? Maybe that's where the thinking goes.
Well, there's certainly a DNA component to this. I mean, the people here that they've already demonstrated, and I talked about John's, and there's not many people with that forensic talent, and there's the antennae to see something and immediately go, something isn't right. And that's not just a talent that you can spread across an entire industry. I mean, that's just something that some people do and others don't. So I think there's no training really to do. I've noted all the training courses that I run, you can't get there if you don't have that natural ability to look at a set of data and go, hey, there's something not right. And geologists maybe are naturally drawn towards, oh, that's a beautiful rock, you know, some version of that. I don't know. Yeah.
I just totally agree. I mean, I'm one of those people that see the crap in the data, but give me a variogram and tell me that that one's right and that one's wrong, and I'll go, okay. Yeah, it is, different people have different skill sets, and you've got to pick the right people. And you know, until Dominic told me I was the QA/QC superintendent at Telfer, and I did 2.5 years of feasibility study running, you know, 10 rigs, looking at the data every day and going to the lab every day. You just don't build up that knowledge base, and you can't learn it unless you do it.
And Renee, James here. I'm pretty sure I asked you the same question in GeoHug talk many years ago, but we'll see if anything's changed. Doesn't sound like it. How can we break this 1 in 20 rule?
Well, so it's the same answer is, I mean, dogmatism is truly where I think the focus needs to be, and you can take that to other concepts of human thinking at the moment, right? And I'm not sure what podcasts you listen to, but there is certainly many things you can copy and paste this to. So the education thing, sorry, I'm kind of tired talking about the education thing, because obviously it is education, but it's a difficult conversation. These events are obviously something that we can do. People like Jessica organizing GeoHug are things that we can do. But you know, I think open source, I mean, the fact that Barry put his paper out open source, that's a great thing to do as well. But you know, we don't live in a culture anymore where we go to bed with a paper on Friday night and sorry, hi, I'm Renee. I got, you know, it's just that's the thing we need to try and create culturally is to be able to discuss and openly challenge each other rather than just dogmatically doing what the previous person did. It's a societal issue more for me. So that's why I'm in kind of philosophical mood at the moment, so as you can tell. But that's kind of where I think the solution lies. And we'll probably break it before we can fix it, to be honest. It's with most of these things.
That's fair enough. But I think it's also telling that I'm pretty sure I'm right in my memory of this now, in Absalom's paper that you referenced and the excellent work about measuring precision. We talk about that. But that paper also covers looking at CRMs with the standard control charts and talks about insertion rates in much the same way.
Look, the insertion rate is just a small part of it. But you know, here's what. So if I get asked to run a training somewhere and there's only the geologist with 1 or 2 years experience, I'm disappointed, because it means that the managing geologist who probably has 5 years experience thinks, oh no, I've done that. You know, and that's kind of where the problem comes from, because then they enthusiastically start calculating precision, and they start collecting half-core duplicates, and then the other half-core disappears, and everybody freaks the fuck out because the whole core is gone, right? And then I get a phone call saying, oh, no, Renee, we're not doing that because it's all, you're way ahead of your time. We're not doing that. We're scared of that. So it is, that's sort of the, I don't know how you feel about that, but it's the scared of changing, the conservative nature of the industry, and the scaredness of changing something that might piss off an engineer that makes more money than you. That's probably, you know, keep it the same. Don't rock the boat. You know, I don't need to collect these duplicates and make the core go away, because then Linda comes around and tells me how your core is gone, and then another BRIEX will happen, right? And that can't happen. So this can.
Yeah, and just on that, I do recall some time ago seeing a project where they had started taking duplicates and they stopped, and the direct quote was, we stopped doing it because they were too different.
No, they were too different.
No, this literally, that line is exactly what I hear every site. We stopped collecting core duplicates because the scatter was too much. And I go, are you kidding me? Because, yeah, but I mean, we're all sitting here preaching to converted, right? So
just to follow up on the conversation, what's your perspective on geologists in general? Do you think we're actually too dogmatic and can't really take on other different ideas? Or I'm really curious about, you know, where you think geologists sit in innovation or ability to think differently or ability not to follow the dogma.
Look, I know, and people are laughing, but it's a good question because this comes down to our institutions that train people at the moment. And again, I don't know what podcast you're listening to, but the whole breakdown of universities as the source of truth and how they teach people. Look at, and I mean, this is not to get political, because I actually have no understanding about the Middle East, but look at the opinions at Harvard graduates about what is going on in the Middle East. It blows your mind. And it's all that dogmatism that just drifts into education. And the same thing is happening here. We just get taught a whole bunch of stuff and that we're all perpetuating. I mean, it's a societal issue. It's nothing to do with geologists. So my experience, the best people that in my company are coming from left field. They're coming from a country across the globe out of a non-mining economy, and they've got some sort of weird collection of skills that allows them to challenge the status quo. And we need more of that, but I don't think it's a geologist thing personally. I don't know.
No, I mean, I don't think geologists are any different from any other career. I mean, do we have a set of characteristics that make us geologists? A love of beer, love of the outback. I don't know, but I think that we are of a type that don't mind bucking the trend, but we're also members of a society that frown upon people that buck the trend as well. So I think there's a bit of indoctrination going on.
Sorry, can you hear me?
Yes.
Oscar. Yes, I have an opinion a little bit outside the box. I think in your presentation, Renee, and my presentation, we were trying to highlight how we can quantify how the impact in the business, how we can quantify risk, what's the materiality of things. I think I've seen in the world a slow change going in that direction. And through that, we are going to be able to go with a dollar value to talk with metallurgists, chemical engineers, and people from finance and marketing. And I think being as a geologist, because of JORC and all those things, we do have a certain idea of KQC or controls in place. But when we talk about sample station, site sample station, port, things change. So there are also opportunities to go in the opposite direction. We normally blame a lot ourselves. We normally blame a lot to the resource model, but it is also about how we execute the production and how we execute the plan as well. So I do see that a little bit outside the box.
Well, I like the out-of-box thinking, and one thing I was going to comment when I saw that, Oscar, I mean, when we talk about objectives, right? So when we say fit for purpose, effectively what we say fit for the objective, right? It's the same thing. So it rolls off the tongue, so we say, it's fit for purpose. But what you really need to define is what the purpose is then. And to me, when I talk about that language soup, game, the purpose can only be captured in 3 words, because that's all we were given. Right? We have no other purpose other than inferred, indicated, and measured. We cannot capture our uncertainty any other way in terms of what will come to us other than by invoking those 3 silly words. And if you go look at what they mean, you go, huh? Right? So if you reverse engineer what you want to do with the data quality management system and quantifying bias and precision and all that sort of stuff, you get really stuck. Because it's really difficult to define. I mean, we talked about, that's why I asked the question this morning of the downhole surveys. Yeah, of course, your paper, the downhole surveys. When is it good enough? Because if it's inferred, you might say, oh, well, a bit of this and a bit of that will be okay. So your purpose is therefore different. So in your SOP, what you are prepared to accept or not needs to specify that wet RC samples are not going to be allowed in an indicated resource, but they might drag into an inferred resource. That's a data quality objective. And once you get on that road, you can actually create a whole framework of data quality ranking. So every sample has a data quality. And Harry Parker talked about this years ago. There's a paper out on that. You can actually model the quality in your blocks, because every sample can get an assigned data quality ranking based on how wet it is, what the QC issues were, whether I the this, the that, whether the colors were good, all that sort of stuff. and you get a number, and you just create that into a block, and then you can have that way into your classification. You have to create that environment. So the whole system approach, Oscar, I'm a full support of it, and it's possible. And if you can build a freaking courtyard to that amount of quality there, you can also do this, right? That's kind of, because that's harder to do. This is actually quite easy to do. It's not fourth dimensional rocket scientist mathematics here. I mean, random number function theory blows my mind. You probably, but this sort of stuff is just A minus B, man. If I talk to duplicates, A minus B, if you square it or square root of 2, doesn't matter, A minus B. We can do this. Yeah.
We'll just have one more question, and that's from Jeff.
Okay, Jeff Phillips, this might be one for a beer, actually.
Oh.
So, JORC, and we've just gone through a bit of a roundtable discussion now of blame and no mention of guidance moving forward. AIG is a member of JORC. I think both of you guys are, got insights into, Rod and Renee have got insights into JORC, which we're not going to try and dig into today. But here's a spoiler alert. Neither one of you mentioned JORC as coming forward with guidance in this space for a total quality management system. So I'm walking out of here with the feeling that whatever's coming out of JORC, A, it's going to be late, and B, it's probably not going to affect us that much. So do we need an international standard?
If so, who's going to do it?
AIG.
I have a comment on that. In this moment, there is a probability to get an ISO on quality. It is in discussion in this moment. So hopefully from here to the end of this calendar year, we can have news, but there is something already happening in Europe in order to have an ISO, a proper ISO on QQC or quality management. So hopefully that is going to end well.
There is actually an ISO document how to calculate precision, right? You can download it. You pay $200 for us, and it's the MAD approach, mean absolute difference approach. But you get a different number to all the other methods that are out there. So when we create a standard, we're going to all sit in a room and fight what numbers we have to use first. So it's going to be a fun game. But I agree. So the JORC is coming up with guidance at least, which is going to be separated from the code itself. So that's a fundamental part, and that allows us to be more creative with what goes into the guidance, because that doesn't have to be updated every single time. So the CIM has that already, obviously, right? If I had a phone call once from somebody in Canada on the OSC after I submitted a report and said, "Oh, you have not submitted enough duplicates in your soil sampling program that you just signed off on." I said, "Are we really doing this? Are we doing that right?" But that blew my mind, because there are clearly standards out there that Canada uses to some degree to control this sort of stuff. So if you would not submit CRMs in Canada, yeah, you're done. But in Australia, you could completely get away with it. So we have work to do for sure. But that hasn't been acknowledged, as far as I'm aware, around the JORC table, and I think it should. So all those in favour, But comment time coming up. But shouldn't that be the outcome of these kind of the conferences? Because we had a mineral resource estimation conference last year, and Jackie Coombs was passionately, crusading for some sort of roundtable of more standards in this space. And I think that's what we need to do to answer the earlier question, because we're all going to go our merry way, and then the next project we're going to submit some CRMs, and we're going to, rinse and repeat. So this needs to lead to work. And it looks to me that it's always the same people organizing this shit. So, whoever's interested, I'm interested to look into that standard making, as you and I have already discussed anyway. So, yeah.
And with that, we are going to close because we all want to drink. So first of all, I'd like to thank Oscar, Rod, and Renee for really thought-provoking and excellent presentations. Thank you.
No, thank you.
And in closing, I just would like to thank Peter for all of the work that he's done behind the scenes. And I really hope that you found today interesting, challenging, and want to learn more about quality management. The drinks are out here for the next hour. Please take the time to talk to the presenters, talk to your colleagues and newfound friends, and I hope you enjoy the evening and safe travels home.